Welcome you all. In this session, we are going to discuss how to design damper winding for synchronous machine. Design of damper winding. Damper windings are provided in pole phases of silent pole alternators. Damper windings are nothing but copper or aluminum bars housed in the slots of pole phases. The ends of damper wind bars are short-circuited at ends by short-circuiting rings similar to end rings in case of squirrel cage rotors. These damper windings are serving the function of providing mechanical balance, provide damper effect, reduce the effect of overvoltage, and damp out hunting in case of alternators. In case of synchronous motor, they act as rotor bars and help in self-starting of the motor. The main purpose of damper winding is to supply the negative sequence field and to damp the oscillation when the machine start hunting. While a synchronous motor and its function is provide starting torque and to develop damping power when the machine start hunting. So the ultimate aim is to reduce hunting in case of synchronous machine. So let us see the design procedure of damper winding. First, let us calculate the mmf of damper winding. The mmf of damper winding is calculated by using the expression 0.143 AC tau. AC represents the specific electric loading and tau represents the pole pitch. And formula to calculate tau is pi d by p, which we know. So the next step is to calculate the total area of damper winding, which is represented by AD. AD is equal to 0.2 AC tau by del D, where AC is specific electric loading, tau is pole pitch, and del D is current density in damper winding. So the next step, you need to calculate the cross-sectional area of each damper winding. So which is represented by small ad and which is equal to capital AD divided by ND, where capital AD represents the total area of damper winding and ND represents the number of damper bars. So in order to calculate this, you need the number of damper bars. Let us see how to calculate the number of damper bars. The number of damper bars ND is equal to pole arc divided by 0.8 times of stator slot pitch. Pole arc divided by 0.8 times of stator slot pitch. And the next step, you need to calculate the diameter of each damper bar. So it is represented by capital DD, which is equal to square root of 4AD divided by pi, where AD represents the cross-sectional area of damper winding and pi is a constant. So it is easy for you to calculate the diameter of damper bar. So finally, you need to calculate the length of damper bar, which is represented by LD, which is equal to 1.1 time of L, where L represents the core length. It's the main dimension of machine, which we call as the length of core. So this is how we used to design damper winding in case of synchronous machine. And the final one is the height of pole shoe HS, which is equal to 2 times DD. DD represents the diameter of each damper bar, which we calculated in the previous step. So that's all about the designing procedure of damper winding in synchronous machine. Thank you.